Okay, so hello everyone. So for this video, we will be discussing the Laplace transform of the derivatives. And for the Laplace transform of the derivatives, so we have this formula. Okay, so it's actually a series and it will depend upon n, okay, or the highest order derivative that we will be using. Okay, so the Laplace transform of the nth derivative of f of t is equal to s raised to n multiplied by the Laplace transform of the function, the original function f of t, minus s raised to n minus 1 times f of 0 minus s raised to n minus 2 multiplied by f prime of 0, and so on. Okay, so as you can see, for the coefficient, okay, so the s, so we will start with s raised to n, then minus s raised to n minus 1, then s raised to n minus 2, s raised to n minus 3 until the last term. So we will have, if n is if the exponent of s will become 0, then until the coefficient of the function here is 1. Okay, and for the function, so we will start with the Laplace transform of t, okay, and then f of 0, and then f prime of 0, f double prime of 0, until we reach the n minus 1th derivative. Okay, so all we need to do is remember this formula. Okay, so let's solve some examples, so using the Laplace transform of the derivatives. Okay, so let's have this one. So first example, so find the Laplace transform of the following functions using the transform of the derivatives. So we are given that we will find the Laplace transform of f of t. Okay, so solution. Okay, so we are asked to solve for the Laplace transform of f of t. Okay, so based on the formula, so we will be needing the derivatives. Okay, so for letter A, so our function is f of t is equal to t cubed. Okay, so we will need the derivative. So there is no rule actually on the number of derivatives that you should do. Okay, so it's just that we make sure that the highest order derivative can be solved using simple formulas for Laplace transform. So although we can already get the Laplace transform of f of t cubed, okay, from the formula, so but this first example is for illustration purposes only. So say for example we want to use the second derivative. Okay, so we will get the f prime of t. So the derivative f prime of t is derivative of t cubed with respect to t, so that will be 3t squared. Okay, and the second derivative, f double prime of t, is equal to 6t. Okay, so from the formula, so again this one, okay, so we will follow this formula. So the Laplace transform, so since we are using the second derivative, so the Laplace transform of f double prime of t is equal to s raised to n, right? So s, and then our n, since we are using the second derivative, our n is equal to 2. So n raised to 2, or s squared, multiplied by the Laplace transform of f of t, minus the next term would be s raised to n minus 1 multiplied by f of 0. Okay, oops. Okay, so the second is it will be s multiplied by f of 0, and then minus, so the next is s raised to 2 minus 2, right? So it will have no coefficient s, and then from f of 0, so our next term will be f prime of 0. Okay, so if we use the third derivative, which we can also do, okay, so if we use n is equal to 3, we can also do that. So n is equal to 3. Our Laplace transform now will become the Laplace transform of f triple prime of t is equal to, so instead of s squared, we will start with s cubed. Okay, s cubed Laplace transform of f of t minus, next term is s squared, and then we still start with f of 0 minus, so we still have s, so 3 minus 2, so that will become s multiplied by f prime of 0, and then minus s, sorry, we don't have s already, so minus f double prime of 0. Okay, so that's how we use that formula. Okay, so it's actually just a series, and again, to solve this problem, so you can either use as much derivatives as you want. Again, so we just make sure that the nth derivative, okay, the highest order derivative, can be evaluated using, okay, so the highest order derivative must be the function, okay, must be the Laplace transform of the highest order derivative can be evaluated using the basic formulas. Okay, so but for in this case, so the second derivative is enough, but we can also solve for the third if we use the third derivative. Okay, so let's say for example we use n is equal to 2. Okay, the nth derivative, so we erase this. Oops. Again, sorry. Okay, so if we use the second derivative, so then the Laplace transform of the second derivative, so our f double prime of t is 60, right? So the Laplace transform of the second derivative is 60 is equal to s squared Laplace transform of f of t minus s f of 0. So we have to evaluate the value of f of 0 and f prime of 0. So from here, okay, so if f of t is equal to t cubed, then f of 0 is equal to 0, right? So if we substitute t is equal to 0, so t cubed will become 0. F prime of 0 also is 3t squared, so that is 3 times 0 squared, so it is still 0. Okay, so therefore f of 0 is 0, and then f prime of 0 is also 0, so s times 0 minus f prime of 0 is also 0. Okay, so now we can solve for the Laplace transform of the function of t. So this is what we are looking for actually. Okay, so because we are asked to solve for the Laplace transform of f of t is equal to t cubed. Okay, so all we need to do is evaluate this, the Laplace transform of the derivative. So the Laplace transform of 60 is that is 6 Laplace transform of t is equal to S squared Laplace transform of f of t. Okay, so the Laplace transform of t is, so 6 multiplied by its Laplace transform is 1 factorial over s raised to 1 plus 1 is equal to s squared Laplace transform of f of t. Okay, so therefore this will become 6 over s squared is equal to s squared Laplace transform of f of t. Okay, so if we want to solve for the Laplace transform of f of t only, so then we need to divide both sides with s squared, so that will cancel out, and then what will remain will be the Laplace transform of f of t is equal to 6 over s to the power of 4. Okay, so which is consistent. So if we, since our f of t is equal to t cubed, then if we just use the formula directly, since we can solve that using the fundamental formulas, so the Laplace transform of t cubed is equal to 3 factorial over 3 factorial over s raised to 3 plus 1. So 6 factorial, that is 3 factorial, that is 3 times 2 times 1, so that is 6 over s to the power of 4. So I'm so sorry, I'm still not used to using this pen. Okay, so yeah, that's it. Okay, so like I said, can be used using the third derivative as well. Okay, as long as the highest order derivative can be evaluated using the fundamental formulas, okay, of Laplace transforms. So we have another problem. So find the Laplace transform of f of t is equal to sine squared of t. Okay, so for example, second example, so if our f of t is equal to sine squared of t, okay, so we have the first derivative, f prime of t is equal to we have, using the power formula, so we'll have 2 times sine of t raised to 2 minus 1, and then times derivative of sine t, so that is cosine of t. So if we simplify this, we have 2 sine of t cosine of t, and then if we use the double angle identity, so this is equal to this is equal to 2 sine t cosine t, so that would be equal to sine of 2t. Okay, so we can still proceed with the second derivative. Okay, but again, we look at the highest derivative. If we can evaluate the highest derivative already with the fundamental formulas of Laplace transforms, then we can just stop now with the derivation. Okay, so as we can see, the first derivative can be solved using the fundamental formulas of Laplace transforms. Then we can stop with the first derivative. Okay, so therefore, we can use the first derivative. So therefore, the Laplace transform of f prime of t is equal to we start with s. Okay, so s raised to 1, so Laplace transform of f of t minus, so we stop with f of 0. Okay, so that's it. So that's the Laplace transform of the first derivative. And then since we are we will be using later on the f of 0, so then we will evaluate f of 0. So from here, so if f of t is equal to sine squared t, then f of 0 is equal to, so sine squared of 0, so sine of 0 is 0 and then squared, so it's still 0. Okay, so therefore we can now substitute the values. Laplace transform of f prime of t, and then f prime of t is equal to sine 2t. So therefore the Laplace transform of sine 2t is equal to s multiplied by the Laplace transform of f of t minus f of 0 is, earlier that was, sorry. So earlier f of 0 is equal to 0. So therefore this is 0. Okay. So we can evaluate the Laplace transform of sine 2t. Okay. So remember the formula, the Laplace transform of sine of omega t is equal to omega over s squared plus omega squared. So this will become 2 over s squared plus 2 squared is equal to s times the Laplace transform of f of t. Okay, so therefore if we divide both sides with s, okay, so dividing both sides with s, so therefore the Laplace transform of f of t is equal to is equal to s over s times s squared plus 4. Okay, so this is now our Laplace transform. Okay, so that's it. So all you need to do is, again, so memorize this formula. Okay, so you have to keep that in mind, and I think it's not very difficult to memorize because it actually has a pattern. It has a pattern, and then you should stop. Okay, so you should stop taking the derivatives if the highest derivative can be evaluated already using the fundamental formulas for Laplace transforms. Okay, so like here, so we stopped with the second derivative. Okay, but actually we can also have stopped on the first derivative. Okay, so in this case, the second one, so we already stopped with the first derivative. Okay, because the first derivative is already enough. Okay, because we can already take the Laplace transform of the first derivative. Okay, in this case. Okay, so that's it. So good luck.